All right, we are going to build some circuits with some capacitors. Couple safety things. First, try to have your area nice and clear just in case. I know I'm doing this on paper so you can see my circuit, but just make sure everything's kind of clear. And then just a reminder that if anything does happen, if you smell smoke or see smoke, always first thing you should do is disconnect your power source that stops any current from going through that circuit. So either pull the battery wire or hit the button just so everything stops. We should be good, nothing too big today, but just really make sure we've got two items. Both capacitors and LEDs are directional. So we really need to make sure that we're putting these in the right direction. Otherwise, we could have some safety issues. Okay. The other thing is making sure we're using the right components, right? So the first circuit that we're going to do has a 1K ohm. Okay, so 1,000 ohms. So this guy right here, again, there's a whole system of the colors of the stripes that you could, I gave a link to last time we were building them, but these ones have them nicely written on them. Okay, also with our capacitors, we've got a few different types. We're going to mostly be using these bigger black ones. They're smaller little ceramic ones as well, but in your kit, but we're going to be using these. So you can see right on them, we've got 100 microfarads and then 10 microfarads. So make sure you're using those correct ones. Also, just like the LEDs, we have a long and a short side. It also tells you on this little gray part, where's my camera? Like that's the negative, and that goes with the short side. So the negative is the short side and the long side is the positive for these. However, I know when I start bending them and moving them, it's not as obvious. So it does show you the negative side of these terminals. Okay. Okay, so I went ahead and drew that circuit right here that we're going to be using. And then I'm just going to show you how to build them. So I'm walking you through these. And the reason for that is because next week we're going to be doing a little bit more complicated complicated analysis, because we're going to be looking at an RC circuit. So this is kind of an introduction on how to use them. And then next week we're really going to analyze the data. So this one's more of a how-to lab, okay? So one of the reflections we did a few weeks ago, you guys all said how much more confident you were in building your circuits, and it was so nice to hear. Now we're adding some more components, so I am going to walk you through, but I did hear that you guys liked the color coding of the wires and a little bit of guidance, so if you're not sure how to do it, you're not setting anything on fire. Okay. I apologize, I lost my voice a little bit, so I sound a little funny, but here we go. Okay, so I'm starting from my positive, and I'm gonna then go to a resistor. In the lab, it is asking you to use 1,000 ohm resistor. We're gonna switch a few of those out, I think, for the second one. Gosh, I don't know what happened to, I had one. They give you lots of these, so hopefully you don't lose them like I do. All right, so in this case, I know before I was using a lot of wires, but we're not making measurements in this case, so I don't feel like I need to use a lot of wires in this case. So again, remembering that breadboards, A through E are connected, and then F through G are connected on those same terminals, or on those same rows. Okay, so there's my 1,000 ohm resistor. I'm then going to put an LED. So this LED, that symbol, you guys looked up the symbols a while ago. That symbol is has those two arrows. That means it's a light emitting diode as opposed to just a diode. Okay, and so, sorry, I'm just double checking because I have my LEDs all bent up. So I can double check which is the longer one and which is the shorter one. Sometimes my kits in my lab room have a little notch on them to tell you which way to go. I don't think these ones do though. Okay, so this is important to go from positive to negative. Oh gosh, I just messed it up again. Okay, mine are not very different in sizes. Hopefully yours are a little bit easier. If you're not sure, just grab a new one. We've got plenty of LEDs in these kits that we don't need them all. There we go. Okay. So I've got positive to resistor to LED. Now I'm going to go to my capacitor. And again, we're going positive to negative. Okay, positive to positive. All right, so please make sure that you're putting your capacitor in directionally like that. Okay, and again, it doesn't really matter what rows you're using as long as these connections are correct. So I use these components all in black because I did not put any extra wires in. If I was trying to test current, I would have used some additional wires, but I'm not for this week, so I'm just going right from component to component. If you would like to put more wires in, you can, but you don't need to. Ta-da, nice and simple. So I've got my positive to my resistor, resistor to LED, LED to capacitor, capacitor back to my negative. Okay, and what you're gonna observe, it happens kind of quickly, so please make sure you're paying attention. Okay, when we turn it on, my button like won't stay on anymore, so I have to hold it. So hopefully you saw, I used my green one just because I thought it was easier to see on this video. And when I keep turning this on, nothing's happening. All right, and so you're gonna go through a few different describing what you're seeing and trying to figure out why, okay? Now, I'm going to skip ahead, okay, and show you that if I test my capacitor, I can see that it is charged. All right, so we need to discharge that. So there's two ways you can do that. Number one, you just connect it back in the circuit, right? So I can take this and kind of bypass this red one. You don't have to take the red one out, but I'm going to. Okay, so then I can connect it like that, but this is actually going to allow it to discharge really slowly. So notice my voltmeter, it's slowly going down. I had my positives and negatives backwards. Okay, and so you can just kind of do this and wait, or there's another way. Okay, you can either use the flat or the metallic edge of one of these, or you can use the metallic side of one of your resistors, and you just touch both sides to it. So I'll use this one just because it's easier to see. Okay, but if you touch on both sides, now this is not something you want to be doing with like a big capacitor or the large voltage, because that will jump. So anybody who's ever had to change a car battery before, you want to you want to make sure that you don't do something like this where you have your positive and negative terminals touch at all, or if you've ever had to jump a car. Okay, that is way too much energy. We're using very small amounts. Okay, so now I can double check this. Oh geez, that is not discharging. Okay, maybe don't use these, I don't know. It worked last time I did this. So if you touch both sides like that, okay, you're just, essentially what you're doing is you're letting this capacitor, you have that charge build up on the positive side and you're letting it jump to the negative side to neutralize itself. There we go. I'm down to 0.1 now. Okay, I must not have. These are kind of flimsy, so when you do push them against each other, just make sure you're hitting both of those. Again, we're using very small current here, and so there's not a lot of energy in here. So it's safe to do that. Do not ever do this on a larger capacitor or anything like a car battery, okay? So now you are all set to add your voltmeter in. When you add your voltmeter, I would connect your stuff to the alligator wires if you still have those, and then you can connect them right to your capacitor. Just make sure when we're doing this, we're not creating any bypasses, meaning notice that my alligator wire connections aren't touching at all, nor is my alligator wire going back to something like an LED or a different wire or things like that. So just make sure anytime you have metal on metal, you're creating that contact, just make sure that you're like these two metallic pieces are not touching. So notice I've got a 0.02 volt there. Okay, again, if I go in and I discharge it, so see how I was able to discharge it back down to 0. Oh, it just keeps wanting to come back. Okay, so that's circuit 1.